In this video, I will present our method PLOP, which is short for Probabilistic Polynomial Object Trajectory Prediction. PLOP takes as input the path trajectory of ego and neighbor vehicles, the front camera image, and the bird's eye view containing the LiDAR points and the object. It outputs 12 trajectories for each vehicle, represented as a Gaussian mixture model, where Gaussian means are generated using polynomial functions of degree 4 over x and y. Let's now observe the qualitative results in an open loop environment on nuScenes. For visualization, input image and semantic segmentation are on the left, the predicted trajectories are represented in the middle, and the future density of probability is on the right. So here, for the stop-and-go scenario, the ego vehicle follows the leading vehicle while stopping at the gate and propagating its own behavior on the neighbors behind it. Next scenario is the lane change. First, the ego vehicle is predicted to slow down while being overtaken, then trajectories bend for the lane change maneuver, and lastly, the trajectory of the vehicle behind us adapts to the ego vehicle speed. Now for the Birdview scenario, since PLOP is agnostic to the number of neighbors, it can predict the behavior of all vehicles during intense traffic without loss of performance. Lastly, the full stop scenario shows the ability of our method to anticipate and displays the consistency of our predictions since the ego vehicle is braking during the full sequence. However, open loop environment is insufficient to evaluate the performance of PLOP for real driving. So we developed a data-driven simulator where the simulated vehicles follows the predicted trajectory using a bicycle model on the PID controller to compute the actual vehicle trajectory. We use LiDAR and camera transformation to simulate inputs along the recorded track and emulate a closed loop. For visualization, input image, simulation status, and semantic segmentation are on the left. The comparison between PLOP and human-driven tracks is represented in the middle, and the instantaneous trajectory prediction is on the right. We observe here the first scenario of the sequence. The navigation command at the left indicates that the ego vehicle has to perform a left turn at the next intersection. The absence of oncoming traffic eases the maneuver, and our vehicle successfully turns left. We fast forward the video on a simple lane following scenario until the next maneuver. Once again, the ego vehicle is asked to turn left, but this time with an oncoming vehicle. It is extremely careful, negotiates the turn at low speed, and then accelerates when the maneuver is completed. We fast forward again for simple scenarios until the ego vehicle reaches a roundabout. We lead the car into taking the second exit using a turn left command followed by a turn right command. We see that the vehicle slows down approaching the roundabout and performs the maneuver at low speed, which is good, but it misses the driving school truck stuck in the roundabout and makes a high-speed error by not stopping behind it. So we reset the simulation, initializing the next input with recorded data and let PLOP drive again. Right after the exit, the ego vehicle successfully performs an overtake on a double parked track. We fast forward the video for the lane following scenario until the ego vehicle reaches a traffic light partially hidden in the leaves of a tree. We see that it slows down for the intersection but does not stop for the red light, making another high-speed error. We reset the simulation and the ego vehicle restarts when the light is green, performs the following left turn and stops at the unobstructed red light. The minimum speed in the simulation is set to 1 km/h to shorten periods when the vehicle is not moving. We fast forward until the last scenario where the ego vehicle reaches an intersection with a green light and negotiates it at low speed. After successfully turning left, the ego vehicle performs a full stop behind another vehicle stopped at a red light. Once the light turns green and the leading vehicle clears the way, our car restarts and follows the traffic. This ends the qualitative results presentation of our method PLOP. Thanks for watching.